We're going to take a look at rational expressions in lesson 27. Start by 27.1 example. How do we add these together? Well, what you have to do is you have to find the least common multiple. Now, the least common multiple, the most common mistake I see is that people will put x plus a as their least common multiple in these situations. And that is not true. That is not your least common multiple here. These x's, they're not the same. They don't combine. What you have to do is treat if there is a sum, meaning an addition, if there's a sum inside or at the denominator, you have to treat it like it's its own identity. So it has its own identity, so therefore it is separate from this x. So when we come up with our least common denominator, or multiple, it would actually be x times x plus a. That would be your least common multiple. So, x times x plus a, x times x plus a. At the bottom, those are switched now. However, we got to figure out what was this one lacking. It already had the x, but it was missing the x plus a. So therefore, we got to multiply the 4 times the x plus a. Because if we're adding the x plus a to the bottom, we have to add it to the top as well. So multiply x plus a. We distribute 4x plus 4a is what we get. The 6 was missing the x. So therefore, add the 6x together. So your answer would be 6x plus 4x. We can now add because we have the same denominator. 10x plus 4a over x times x plus a would be your answer. I mean, that's how you do these rational expressions. Let's look at a couple more. Example 27.2. 27.2, x plus 2 over x plus 4 plus 6 plus 2 over x squared. Now you can see I already put in parentheses the x plus 4 to show you that it's its own identity. It is separate from the x squared. This x squared has nothing to do with this x because it is a sum in the denominator. So our least common multiple is x squared times x plus 4. So I write that to the bottom of all these. And we're going to now find out what each one was missing. This one already had an x plus 4. So the x plus 2 just needs the x squared. Well, you still got to multiply it. You don't just add it in there, you multiply it. So we got to multiply the x squared by the x and the positive 2. So we distribute x squared times x, x cubed, x squared times 2, positive 2x squared. This 6 right here, it had nothing. It didn't help us at all. So we need to multiply the 6 times, x squared plus times x plus 4. So the x squared kind of joins along with the 6 here. So we got to distribute 6x squared to the x and the 4. 6x squared times x, 6x cubed. 6x squared times 4, 24x squared. And then the last one, this x squared, or 2 over x squared, it is lacking the x plus 4 from the least common multiple. Distribute, you get 2x plus 8. Now we can start adding like terms because everything is over the same denominator. Like terms, x cubed, 6x cubed, combined to be 7x cubed, 2x squared, 24x squared, combined to be 26x squared, and these have no like terms, so they stay. So you have a nice long answer, but there you would have it. That would be the answer in 27.2. Want to look at one more that's a little bit different. Example 27.3. It gives you this. Well, the difference is we have a trinomial underneath the x plus 2, or in the denominator. What we need to do first is factor. We want to factor. So what multiplies to be 3 and adds up to be 4? We did this a couple lessons ago, or even last lesson, whatever it was. Multiplies to be 3, adds up to be 4. Well, that would be a positive 3 and a positive 1. It's pretty easy right there. And then you have minus 1, get that part. You have x over x plus, or x times x plus 1. Okay, so what do we notice here? Well, all these are actually products. So if they're a product and we have two of the same identities, x plus 1 and x plus 1, they can combine to be 1. So therefore, our least common multiple would actually be x times x plus 3 times x plus 1. So this one is missing the x. Add it in. Add it in here. Distribute in the numerator, x times x, x squared. X times 2, positive 2x. This one was missing x plus 3. Key note here, when we distribute this 1, do not forget that it is actually a negative 1. Got to distribute a negative 1 to the x and the 3. So negative 1 times x is negative x. That sign says that. Negative 1 times 3 is negative 3. Many of y'all, or not y'all, but many students often mess that part up. So now that we have this, got a common denominator, can add the numerator together. X squared on its own, 2x minus x, like terms. X squared plus x minus 3 all over x times x plus 3, x plus 1. There is your answer, and that is how you do rational expressions.